I don't know that I've actually showed you guys this. I did put these on your form quizzes in algebra 2. I don't remember. This is trig identities, which requires a whole lot of memorization. A whole lot of memorization. First off, you have what we call the quotient identities. You see quotient, you're thinking fractions. Fractional identities. Sine of theta is the reciprocal of what? What is sine the reciprocal of cosecant? So you can write it as 1 over cosecant. That's all they are. They're basically the reciprocal identities. What's cosine the reciprocal of? Secant. So 1 over secant. How about tangent?
Cotangent.
Tangent is the reciprocal of tangent. Sorry, tangent is the reciprocal of cotangent. That's all you're doing. You're just writing them out in their fractional forms. There's 3 more. So we're talking about sine, cosine, tangent. We're talking about cosecant, secant, cotangent.
That's such an obvious word.
What's such an obvious word?
The wordle.
Oh, the wordle.
You good?
Good.
How many?
4 tries.
You've got.
Anyways, cosecant's 1 over sine. Secant will be 1 over cosine. And then cotangent be 1 over tangent. I guess it's probably about time I started giving you guys form quizzes again. There is a lot of stuff in trig you have to memorize. Hold on. Oh, you know what I also did? I put this in the wrong spot.
I just did all that.
I don't know why I did that. Probably because it's Monday morning. I had something in my head that wasn't right. Let me change that text. Those are actually the reciprocal identities, isn't that what we were talking about?
Yeah.
I said fractional and I just started writing down the first thing I thought. These are the reciprocals. And underneath that would be the quotient. It's a good way to start off notes. Completely wrong. It's 1 over, I don't know.
You wrote 1 over tangent. Well,
That's entirely wrong. I'd like to say that I had just noticed I put things in the wrong spot. There we go. That fixes that.
do you mean the other way for him?
Maybe it doesn't fix that.
What is going on?
I don't know, Cora. Cotangent.
Oh, I wrote it down.
Tangent. Hopefully you wrote it right.
I wrote it right.
Anyways, the actual quotient identities, they deal with what tangent and cotangent are in terms of sine and cosine. I don't know if you know these or not. Think about your circle quizzes. That little box in the lower right-hand corner. What do you write down for tangent?
Roberts.
Y over x. What was y?
Sine.
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 Sine over cosine. Tangent of theta is sine of theta over cosine theta. And how about cotangent then?
That's what I'm saying.
Cosine over sine, reciprocal. So there's 8 things. There's probably a whole lot more. This is trig identities. Other than the screw up I did, anybody any questions? All right, what's up next in here? Pythagorean identities. Thursday or Friday, I don't remember which day it was, we wrote down one of the Pythagorean identities, we derived it. Remember what we derived? It gave me the standard form of the circle. Yep, that's the one we derived. That's the first one. Sine squared of an angle plus cosine squared of an angle is 1. And we're going to manipulate that thing and come up with 2 other identities. So we're going to derive 2 more. I'm going to take sine squared of theta plus cosine squared of theta equal to 1. And I'm going to divide all 3 pieces by sine squared. Oops, I don't need the plus symbol there. And the very left-hand side, sorry, the very right-hand side of that says 1 over sine squared. What's 1 over sine?
Cosecant.
Cosecant. So what do you think 1 over sine squared is?
Cosecant squared.
That's what it is. Doesn't take huge leap of faith to establish that. This becomes cosecant squared of theta. How about sine squared over sine squared? 1. Ignoring the squares, let's cosine over sine. Cotangent. But they're both squares. Okay. Cotangent squared. All right, there's the second one. 1 plus tangent squared of theta is cosecant squared of theta. And in a perfect world, you memorize the first, you memorize all three of them, but the reality is what you tend to do is you memorize the first one and derive the next two. It's not hard to do.
The second one's divided by cosine.
The second one's going to be divided by cosine squared.
Okay, I should have written that down there. Where did cotangent square come from? 'Cause
Cosine over sine. Cosine over sine is cotangent, right? Look at the previous slide. You told me that.
okay, yeah, that's a question. I'll put it.
But anyways, Jaden's right. Instead of dividing by sine squared, what can we do? Divide by cosine squared and see what happens. And if you look at your previous slide, what's sine over cosine? So sine squared over cosine squared, tangent squared. Cosine squared over cosine squared? 1 over cosine squared, secant squared. Those are the three Pythagorean identities in trigonometry. Oh wait, there's more. There's always more.
You did 1 over cosecant. Did you do that? Did you flip your number out?
Nothing's wrong. 1 over cosine squared is secant squared. If you look at your previous slide, you have 1 over cosine being secant. But since they're squares, it's got to be secant squared.
Why is your 1 on this side?
Because in the middle,
Wait, are you dividing by cosecant squared?
no, this was
Oh.
This is the second one.
Oh.
I erased everything I had because I just don't have much room up here.
What did you used to have though?
Cosine squared.
Where are cosines?
To derive the second
You're
one.
dividing everything by cosine squared?
Yes, once you do the one thing, you have to do all things.
Oh, jeez. Okay, almost.
So did you get the 1 plus cotangent squared is cosecant squared?
Yes.
Okay, well, I rewrote sine squared plus cosine squared as 1. And then I went through and divided everything by cosine squared.
You rewrote what as 1?
I rewrote this,
Yes.
and I divided everything by cosine squared. That gives you the third one. Here's the even odd identities that I can get off the phone. Even odd identities. Let's see here. What do you know about the sine of pi over 4? Tell me where it is. Root 2 over 2. It is 45 degrees, but I want the actual ratio. What do you know about the sine of negative pi over 4? It's negative root 2 over 2. This is actually what we call an odd identity. The sine of a positive angle was root 2 over 2. And the sine of the negative angle was negative root 2 over 2. And sorry, the sine of a negative theta is equivalent to the negative sine of a positive theta. I don't know if what I wrote up there explains that, but if you just take that negativity, if you know the sine of a positive angle, you also know the sine of a negative angle, as long as you make it negative. Because you see what happened? We went from positive to negative. So the sine of a negative angle, you can just move the negative symbol in front. That's how it works. You don't have to concern yourself with negative angles. Just make it positive, move the negative symbol out front.
So it's just like the same as square root. No, it does not thing. That's long.
I believe it also works for the tangent ratio. Talk about the tangent of pi over 4. What's tangent of pi over 4? Tangent of pi over 4. It's root 2 over 2 divided by root 2 over 2. You mean you can't do it? Root 2 over 2 divided by root 2 over 2.
It's got 2 over 2 times 2.
You're doing too much.
Yeah.
It's something divided by itself.
1.
1. Now, what if you're down here? The tangent of a negative pi over 4. Negative 1. The same rule applies. If you want to know the tangent of a negative angle, all you got to do is find the tangent of the positive angle and make the result negative. Just a shortcut. I don't know if it buys you anything. It's just a shortcut. I mean, you don't really have to worry about negative angles if you remember that. That's all it means. Last one is cosine. By the way, we call these odd. So even or odd identities, those are the odd ones. Because the sign changes. Last one would be cosine. So again, I'll stick with cosine pi over 4. This is cosine pi over 4. 2 over 2. But if I talk about being down here, the cosine of negative pi over 4, it's the same thing. So the even one just says when you're talking about cosine, just drop the sign altogether. Cosine of a negative angle is exactly the same as the cosine of a positive angle. Hopefully that helps make some sense. If not, you just memorize them and trust that they're right.
Cosine of a negative angle is not negative cosine of a
Nope,
positive?
because they match. See the little table we made? The cosine of a positive pi over 4 was root 2 over 2. Cosine of a negative pi over 4 was the same thing. When you're dealing with cosine, nobody gives a crap about the sign on the angle. It doesn't matter. You just drop it. That's all it means. Are you doing anything interesting yet? Did you find me a proof coming up maybe?
This is so much.
Using algebraic techniques to simplify trigonomic equation expressions.
I know it is.
A lot of big words.
Just what you see next, simplify. Simplify this expression by rewriting. These are just techniques to actually build you up to what's called proofs. Simplify a tangent of theta over secant of theta by rewriting each trig function in terms of sine and cosine functions. So look back at your reciprocal identities. What's tangent if you look at the reciprocals? That's quotient, which might actually work. No, that's fine, that's fine. You're looking at that, that's right, you're in the right place, I'm not. Tangent is sine over cosine. I agree with you 100%.
Didn't we do a little bit of this last year?
Yep.
Oh, yeah.
I never tested you on it, because I knew what the kind of result it would be.
I remember seeing.
Already gave 2 and a half, so. How about secant? 1 over cosine. So everything has been written in terms of sine and cosine. Yeah, this thing can be cleaned up quite a bit. There's two ways of doing it. You could divide by a fraction by multiplying by its reciprocal. That's the long way of doing it. Things in corresponding positions, what do?
That's allowed.
They cancel.
That's just sign.
Yeah, it ends up being sine over 1. You just sign. So that's the train of thought you can do. When you see some of these functions, you can rewrite them in terms of sine and cosine. The next one is show that sine of theta is 1 plus cosine theta is equal to 1 minus cosine theta over sine theta by multiplying the numerator and denominator by 1 minus cosine of theta. What is the relationship between that piece and that piece? They're conjugates, not reciprocals, they're conjugates. It's a conjugate technique. This is why we teach conjugates. Actually, it has nothing to do with the fact that you're not supposed to divide by a irrational number. That doesn't matter. It really doesn't. It's just some rule somebody came up with to force math teachers to teach conjugates. That's the only reason it's taught. To embrace the idea of a conjugate, because if you multiply something by its conjugate, you make it appear different, which is important in a calculus class. Okay? So our goal is to prove the left is equal to the right. That's all it is. And their suggestion is to multiply the left-hand side by the conjugate. I haven't done these in a minute. And see what happens. What property can you use to handle the numerator? Distribute. All right, I know it's a little funky. Sine theta times 1. Sine theta. How about sine of theta times a negative cosine theta? Minus sine cosine theta. Now, I'm going to highlight this piece right here just as it is because I may come back and want that instead. Okay, sometimes you want the distributive result, sometimes you don't. All right, so keep that in mind, that created that, all right? What would Jesus do in the denominator? Recoil it. 1 times 1, still 1. 1 times the negative cosine? If you remember anything about multiplying by conjugates, things disappear. Still do. 1 times the positive cosine. Cosine theta. And then cosine theta times the negative cosine theta. Cosine squared theta. Having fun yet?
Almost just.
What you guys need to figure out is you need to look back at your Pythagorean identities and figure out what cosine squared of theta is. Look at your Pythagorean identities and figure out what cosine squared theta is. That's exactly what it is. I don't know if you were actually listening to what I was telling you, but you go back to this identity, cosine squared plus cosine squared is 1. And you just shift the sine squared over. That means that cosine squared of theta is 1 minus sine squared of theta. Which means wherever I see cosine squared theta, I'm 1 minus. Now I actually am going to go back to this. I'm going to leave that in its factored form. Sometimes you use the factored form and sometimes you don't. You'll see in just a minute why I'm doing this. Cosines cancel out. There's a negative symbol. 1 minus sine squared theta. And there's a negative symbol there, so I've got to encapsulate. Because I'm taking away 2 things instead of 1. What's the denominator become? You have 1 minus 1 minus a negative sine squared theta.
Sine squared.
That's sine squared theta, doesn't it?
What'd you do with the numerator to get?
I went backwards to what it was originally. I remember I highlighted this and I said I might go back to this. That's the technique too. Sometimes you don't actually distribute the numerator. I remember being a kid, I would do this and I'd be like, does that factor? Yes, it does factor. So a lot of times,
And then on the bottom, those cosines canceled out, and you just change cosine squared to the other thing that we found.
substitution probably. That's why there's memes all in these notes. These things suck when you first see them.
But you got 2 cosines on the top.
I had a negative cosine
A
plus
negative and
cosine.
a negative and positive.
They cancel each other out. They're nothing.
Oh, that's why the one is on the top.
Now, the reason I went back to what I originally started with is because I know the next step. That's why. The first glance at this, I was thinking maybe I need to do it, but I didn't do it. Bottom becomes according to Brody's sine squared. He's not wrong. I'm leaving the top factor. For a reason.
There's sine theta on the bottom.
Hold on. Yeah, that's what I'm looking at. I'm looking back to x over x squared. Remember doing stuff like that, x over x squared? So my attention is, most of you saw that, good. I'm thinking about this thing. Sine over sine squared, it's got to be 1 over sine. Has to be. So throw that away, decrease the exponent by 1. And that 1 minus cosine of theta sitting over sine of theta.
Why is it negative?
Why is it 1 negative?
Okay.
I believe that's what they asked you to prove in the first place, wasn't it? I said rewrite it. Fun stuff, isn't it? If you can figure this stuff out, like you'll never struggle in math again. I mean that. I mean, you just, something clicks. All the logical moves you gotta make, so just click. That's the next strategy. Simplify 1 over 1 minus the sine of u plus 1 over 1 plus the sine of u by rewriting the expression over a common denominator. This is the LCD method, valued functions. That's all it is, nothing more. There's lots of ways of teaching this. Anybody know what the LCD would actually be? Okay, let's just go over how you add A over B plus C over D. Let's do that. How do you add A over B plus C over D?
A plus C over B.
B times C.
You give AD,
Butterfly.
and you give BC or CB, and you unify the denominator. So you add 2 fractions together. What you guys are usually taught was find the least common denominator, which is fine with numbers. These aren't numbers. They're not numbers, okay? And that usually creates the LCD. It doesn't always, but it usually creates the LCD. So I'm looking at 1 over 1 minus sine of u. What am I giving the 1?
1 plus sine.
Mhm.
Does that mean just, is that kind of like the same thing as sine theta, they're just replacing theta with something else?
Yeah, it's letter u this time. So I give 1 a 1 plus a sine of u. Plus, I'm looking at this one, what's it give?
Minus.
1 minus sine u. And what do I do with the denominator pieces? Multiply them together. And clean the thing up. Up top, what do you have?
1 minus sine equals 1 plus sine.
Which is?
Plus sine is
2. Look at that, let's see if you figure it out. I believe the top is 2. You have a positive sign and a negative sign, and you're adding in between, they're gone. All that's left is a 2. How are you going to handle the denominator? So boil it.
So just 1 minus sine squared.
And that's a good start. That's not the fully simplified version. You know why?
that's close to 5.
That's cosine squared, isn't it? That's a hard thing for some kids to get. You know, I'll say it often, if you start seeing squared things, go back to this. Think about that. Think about those Pythagorean identities. Write them down, manipulate. It turns out that 1 take away a sine squared is what? Cosine squared. So this becomes 2 over cosine squared. And you're still not done. You don't actually have a rule for this, but somewhere you have 1 over cosine, right? What's 1 over cosine? Secant. Well, what would 1 over cosine squared be? Secant squared. And there's a 2 here. So what is it?
2 secant squared.
It's 2 secant squared. I don't know why I switched from u to theta. I'm sorry. I didn't mean to. Just getting the habit of drawing the theta.
1 over cosine is
Secant.
so that just makes it secant squared.
And again, I don't know why I switched from u to theta. Don't have a clue. Next one's got your favorite F word.
Friends.
Friends. Only if it's with benefits. No, nothing. Solve by factoring. Fudge. Well, what do you see in the bottom?
Sine times 1 plus cosine.
Well, what do you see that you can factor down? Sine. 1 minus cosine squared of a v over sine of v times what? Nope.
1.
1.
What do you do with your cosine?
It's still there. It's 1 plus cosine v. You gotta have that 1 there. Think about what you wrote. What you were gonna write wasn't correct because you couldn't get back to the original. So, is it simplified or not? Why not?
You still pull stuff out.
You can cancel out a cosine.
No, you cannot.
Well, they're squared.
Yeah, but the other one is a plus operation. There's a minus and a plus down low. When you're seeing minus and plus symbols, you can't just cancel out. You can only cancel out common factors. Not common sums, common factors.
This is nothing to get from me.
Nope, because you have never wanted to believe that rule is true. I've even shown you 3 times the numbers, your rule doesn't work. Yeah, 1 minus cosine squared. Just take a look at this thing. Move your cosine squared over. Sine squared is 1 minus cosine squared. You start seeing those square things. Look back at those Pythagorean identities. This is sine squared of theta over, sorry, not theta, v, over sine v, 1 plus cosine v.
Now you can cancel.
Now you can cancel. What's the sine square of v over sine v?
Sine v.
This is sine v
Plus cosine.
over 1 plus cosine v. That is as simple as she gets. So, Cora, hopefully you'll finally figure out that you can't just cancel out whenever you feel like it. Common what? Common what? Factors. It's always common factors. Come on. Too far. Oh, establish the identity. So your goal on these is pretty simple. Make left hand equal to the right hand. Proving the left hand is the same as the right hand. Sometimes it's the other way around. Sometimes you have no choice. Make the right hand equal to the left hand. Sometimes it's just easier to work with the right hand side than the left hand side. I, however, have no idea how to work secant backwards to get the left hand side. But I know that the left hand side has lots of things I can do. I mean, what's your gut say when you see it?
Do it with sine therapy.
This isn't a, we're not going to do our usual stuff in algebra where we divide out. We're only going to manipulate one side. Okay? Not the first kid I've seen do that. So it's a valid move, but we're only going to play with one side of the equation. Show you that sign. And while we're at it, why don't we rewrite cotangent and tangent? What's cotangent? Rewrite in terms of sine and cosine.
Yeah.
How do y'all already know these?
That's why we're at something.
Some people can memorize things pretty instantly for a time.
Cosine, sine, sine.
By the way, I am distributing here as well.
You're doing it at the same time?
Yeah,
You can't do that.
yes you can.
Not with me.
It would be sine squared equals cosine.
Oh, never mind. I see what you're doing.
If I had rewritten cotangent right, it would make more sense, wouldn't it? I actually switched them around by accident.
You wrote the tangent twice.
Cotangent is cosine over sine.
Oh. Thank you. You wrote something twice.
I mean, it wouldn't matter, would it?
Yeah, in this problem, no. But they have to be different, don't they? Wouldn't matter, we have swap them all now. All right, what's sine times cosine over sine? That's just cosine. How about sine times sine over cosine?
Sine squared over cosine.
Fudge. Not what I want yet.
We'll do something secret.
Hmm?
We'll do secret.
We're not gonna play with the right hand side. The goal is to make the left hand look like the right.
Wait,
Whenever I'm done with this particular piece, it had better say secant. So I'm not done.
2 plus secant is cosine. No.
Make it more secret.
No. You could make cosine 1 over secant. Add two fractions together. You have two fractions there. Add them together, see what happens. What do you give this cosine? What do you give it? You give it that guy, don't you? What do you give sine squared through multiplication? It's 1. What's the denominator do?
Cosine squared.
Times a 1, right? I'm going to show that because y'all are so bad at adding fractions by hand. Not necessarily horrible at the numbers, but. All right. You're almost there. What's the numerator become?
1
Yeah, but what's the intermediate step?
cosine squared plus sine squared.
The intermediate step is the numerator is cosine squared plus sine squared. Sitting over a cosine of theta. And that's the first Pythagorean that you learned last week. Cosine squared plus sine squared is what? 1. R1 over cosine.
Wait a second. Did I miss something?
I have no idea. Figure it out and tell me what
Why
you're
did,
going to get.
okay, last thing I had was cosine squared plus sine squared over cosine.
Mhm.
Why does that not just mean cosine squared plus sine squared?
Because it's all over a cosine.
Yeah, so that doesn't one of your cosines cancel out?
No.
Cosine?
No.
Is cosine a factor of both pieces of the numerator? Do both pieces of the numerator possess cosine? No.
Okay, then redo what you just did. What happened?
Look at your Pythagorean identities. You have written down sine squared plus cosine squared is what?
1.
So I
So-
see sine squared plus cosine squared. You have
The
an
top
idea?
thing was 1,
Yeah.
so it becomes 1 over cosine.
Yeah.
Oh. Then what was the next thing you said?
Nothing. Just telling you to look at your identities.
You said something else. I didn't listen.
You gotta quit canceling out things that aren't factors.
Yeah, it's starting to look pretty ugly on my paper.
Only cancel factors. Oh, yeah, that was your SpongeBob thing. Use your imagination. This is like a really easy
We
one.
finished that?
That was done. Did you make the left-hand side look like Seagull?
No, hell no.
You
1
wrote,
over cosine, that's all I have.
what is 1 over cosine? This is like really easy. I'm not even sure why it's in your notes. What happens to a negative when you square it?
It becomes positive.
So what is the sine of a negative theta squared? Just sine squared, isn't it? Oh, it is. What you're supposed to do is you're supposed to think like this. Negative sine of theta all squared. That's what you're supposed to think like. What's going to happen to the negative sine when you square it? Positive. When you see cosine square, cosine of a negative angle, you're supposed to refer back to that identity, the even odd. It just says make the angle positive, doesn't it? And you get it right there. Because sine squared plus cosine squared again for the umpteenth time today is what? 1. Left-hand side looks like right-hand side. I actually enjoy this stuff. Y'all probably not so much.
I like it when it's solid.
Kind of like puzzles, what it is. Probably the last one we'll do in class today. What time do you guys get out of here? Huh?
4 minutes.
No, then we'll just save this for tomorrow. I don't think it'll be done in 4 minutes. I wonder if Kyle watches this stuff. I wonder if Taylor watches it.